In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. It is the showstopper of our solar system. Basking in its own glow, it seduces all admirers. However, it is a beauty with a mean streak. It's a massive, frigid ball of gas, surrounded by icy rings, hurtling at 40,000 miles an hour. It is a planet of violent weather, with a polar storm bigger than the United States of America.
Saturn has some of the most powerful weather in the solar system. The lightning can be 1,000,000 times more powerful than lightning here on Earth.
But its moons are even more exciting.
The geysers on Enceladus are erupting water vapor hundreds of miles into the air because of the much lower gravity there and the fact there's no atmosphere holding them in.
Another has an atmosphere with oceans and mountains. Could life exist on one of these moons? Saturn, Lord of the Rings. If there is one planet that represents the majesty, mystery, and awe of the universe, it is Saturn. It stirs emotion, even from scientists who are stunned by its cosmic perfection.
You gotta hand it to Saturn for being the most beautiful thing out there. It's been my favorite planet since I first saw it through a telescope.
While it looks sleepy and serene, the sixth planet from the Sun is anything but. Saturn is a dynamo whose beauty is skin deep.
Saturn is an absolutely frigid place. You wouldn't want to step out on the surface. For one reason, you'd fall because there is no surface, but secondly, you'd freeze to death instantly.
Saturn is a hunk of hydrogen and helium that races around its axis, distorting its shape.
When you watch a professional toss a pizza, as it spins around, it flattens out. So it's the same kind of idea. Because it's spinning so rapidly, it's actually sort of squashed, sort of bulges in the middle. It's called an oblate spheroid.
Even though it's much more massive than our own planet, you'd actually weigh slightly less on Saturn than you do on Earth. A 150-pound human would weigh only 137 pounds on Saturn. That's because Saturn has such a low density, the only planet in the solar system less dense than water.
Saturn is so bloated, the gases take up so much space compared to the total amount of mass in Saturn that its density is less than 1. So if we could get somehow some really big ocean and put Saturn in it, it would float.
Saturn is the second largest planet in our solar system. It is a gas giant, a mass of hydrogen and helium 750 times the size of Earth. A day on the planet is 10.6 hours long, and it takes 29.5 Earth years to orbit the Sun. It has 48 named moons. Saturn has been around for 4.5 billion years. It formed by accreting carbon dust particle by particle into a rocky core several times the size of Earth. Then it was able to attract gases like hydrogen and helium, which collapsed under gravity.
As things started collapsing, this cloud began to compress. It began rotating more rapidly, but along its axis from, let's say, top to bottom, it wasn't rotating, so it was free to collapse under the force of gravity.
It's called the conservation of angular momentum, a principle on display at your local ice rink.
If you push your arms out, if you're an ice skater, you'll go more slowly. If you pull your arms in, then you'll be more concentrated towards the axis of rotation and you'll have to spin faster. And that's just what happens for a planet as it condenses.
A spinning Saturn came out of this collapsed disk. The feature that has made Saturn the most iconic planet in our solar system is her majestic, shimmering rings. They are incredibly big, 173,000 miles in diameter, wider than 21 Earths side by side.
So it would take you 2 days in a really fast rocket ship to get from one side of the rings to the other. They're huge.
However, these huge rings also are unbelievably thin, measuring about 65 feet. When viewed from the side, they virtually disappear.
They are no thicker than about 1, maybe 2 stories in a modern-day building. They're paper-thin in comparison.
The rings may look like perfect solid disks. However, they are actually made up of billions of pieces of space debris. But what exactly are they?
They are countless icy bodies that range in size from objects as big as houses all the way down to the finest powdery snow you might ski on in Utah. And they're made of water ice.
They're particles that have been pulverized, so they've smashed into each other. They've broken up into many, many little particles.
If you were to be inside those rings, it'd be like in a beehive. They're all over the place, so bees in a swarm. It's a hostile place. You do not want to try to put a spacecraft through those rings.
And these particles spin very fast.
And they're screaming around the planet at 20 to 40,000 miles per hour.
The inner rings spin faster than the outer rings, and there's a reason for that.
Kepler's laws say that if you're going to orbit in a circle around a central body, if you're close up, you move really fast, and if you're far away, you move really slow.
If a particle the size of a grain of sand moving at hypersonic speed were to strike a spacecraft, it would be like a shotgun blast at point-blank range.
Now get outside the rings, things are much quieter. If you want to take a country drive around Saturn, go this way instead of following the rings.
Why the rings are there is one of the planet's great mysteries. The rings might have once been some of Saturn's moons that got too close and smashed into each other. The fractured pieces were held by the planet's gravity to become its rings. According to another theory, something big and fast might have crashed into one of Saturn's many moons. The broken shards were sucked in by gravity and fell into orbit, forming the rings. Although scientists disagree as to how the rings were formed, they do agree as to who first studied them. In 1610, the Florentine astronomer Galileo Galilei first noted the rings of Saturn.
He saw these little things sticking out on the side of the planet. He had no idea what they were. So like any good astronomer, Galileo kept a journal, and he wanted to write into his journal what he had seen, but he didn't have a word for it. So in his journal, right in with the words, he drew in a drawing in place of a noun, and this is what he drew. Here's Saturn, and here's these two things. Unfortunately, Galileo never really figured out what it was. We had to wait for a later astronomer to do that.
45 years later, a Dutch physicist, Christian Huygens, had an answer. He knew that there wasn't just one ring, but several giant rings. Today, there are 7 known ring regions.
There's the A ring, the B ring, and the C ring. So those are the 3 main rings. There is a ring interior to the C ring called the D ring. And once we got there with Voyager, it showed us the F ring in all its glory. And then there are some diffuse rings outside, the E and the G ring.
Each of these rings has a different personality. The A ring is almost transparent, which is why light easily passes through it. The B ring is dense, chock full of material. The C ring is even more transparent than the A. while the D ring is barely there.
There's a lot of neat things in those rings, so you can't think of them as a homogeneous body. You got to think of each particle inside those rings and what each one's doing.
These distinct qualities are what we see as colors, shapes, and shadows, the wonder that is Saturn's rings. The reason we can see them at all is due to the sun. Just as our moon glows with reflected sunlight, so do Saturn's rings. It is a phenomenon called ring shine.
Just imagine yourself on the night side of Saturn looking up and having the rings just completely covering the sky. It's much brighter than the Earth on a full moon.
They shimmer, and they're brilliant, and they're bright. And that's because they're mostly made up of ice particles, which reflect a lot of sunlight.
However, there is evidence that the glowing marvels of our solar system won't be around forever. Some scientists are asking, just when will they disappear? For all scientists know about Saturn's rings, they remain a huge mystery. When they appeared is a point of much debate. Scientists used to believe that the rings were formed at the same time as Saturn, 4.5 billion years ago.
But because we don't understand what holds the rings together, and our best guess as to how long the rings could stay together is only a few 100 million years, there's something wrong with this picture.
There are reasons to believe they're no older than a few 100 million years old. Those reasons lie in trying to estimate how much erosion is taking place on the rings because of the hailstorm of micrometeoroids, small, tiny bodies that, particles that come in at a tremendous speed and chip away at the rings and therefore erode them.
Neptune, Uranus, and Jupiter also have rings, but theirs are sparse and dim. Saturn's are bright and full, leading scientists to suggest that they haven't been exposed to erosion for long, and therefore are relatively new. But does this gradual erosion mean that Saturn will lose its most magnificent feature?
The idea is that over, long periods of time, the material can just get so small that it can be charged, end up acquiring a charge in Saturn's magnetosphere, and then it can just get zipped away, taken away by the magnetic field. Or it just spirals into Saturn itself. That is a scenario for the death of the rings, is that they finally get eroded away.
In order for Saturn to continuously have rings, they need to be refilled.
At the moment, Saturn has a tremendously large ring system, but the actual material in the rings does have to be replenished.
Strangely, another kind of assault might be necessary to preserve them.
They have to get renewed by an errant comet coming in and crashing, adding to the mass that's going around there. And that kind of question is still being debated.
The debate continues when theorizing as to when the rings will vanish.
Hundreds of millions of years, probably, maybe billions of years, we don't know. That's a matter of debate right now. Whether the rings are young and are going to die an early death, or they're old and they're going to remain with us for a very, very, very long time.
Of Saturn's 48 named moons, there are small moons called shepherds, for good reason. They have gravitational pulls that help keep the rings intact by herding the particles. Saturn's experts are interested in the complicated choreography between the planet's moons and its rings. The contorted F ring is especially intriguing.
And then there's the two shepherd satellites on either side, Prometheus and Pandora. And they are having gravitational effects on this ring. It's being tugged in a variety of directions. So it looks wild and, misbehaved, if you will. And it's a dynamicist's playground. I mean, we're very, very interested in watching what happens to the F ring because it tells us how moons interact with rings.
Saturn mesmerized civilizations as early as 700 BCE, when the Assyrians took note of it sparkling in the distant sky. Hundreds of years later, the Greeks gave it a name, Kronos, after the god of harvest, possibly due to its position in the sky during harvest season. The Romans' god of agriculture was Saturnus, which is why we call it Saturn. They also named a day of the week after him, what we now call Saturday. However, had the Romans actually seen the planet close up, they might have named it for the god of weather.
Saturn is a wild, ever-changing place, but unlike on Earth, where things change on a daily and even an hourly basis, the storms on Saturn can last for days and weeks and months, and things change on a large scale very slowly over time.
The discovery of this violent activity on Saturn came as a surprise to experts. For centuries, their view of the planet had been obscured by an ammonia gas haze. New satellite data is changing everything.
And we see now that Saturn is a dynamic place. It's been revealed now as being probably more dynamic in a lot of ways than Jupiter. Just the number of storms we see, the motions that they do.
Incredibly, winds blow at speeds of 1,000 miles per hour.
We measure the winds literally by watching the different little cells of the atmosphere move in imaging. So you need sequential images to see how much things have moved. There are no mountains on the surface of Saturn. It's cloud features that we look at to see how quickly they evolve and change and move to measure the winds.
Recent exploration has shown other phenomena that aren't yet understood.
We can see features, clouds, eddies, big plumes of material like we see on Jupiter. And we see these oval storms, lots of them. In fact, there's one latitude in the southern hemisphere where lots of storms zip around this band, okay, and we've watched them be created. We've seen them die. They die by merging.
Scientists nicknamed this area Storm Alley, after a region in America's Midwest that produces violent weather. It is believed there's lightning there, though no one has seen it.
And there's a technical reason for that. To see the lightning, you have to get around on the night side, and because the lightning flashes aren't all that bright, and so you need the darkness. But the night side of Saturn is very bright because of all the ring light that shines down on the night side of Saturn, and so it's very hard to sort the lightning from just puffy little clouds.
The hellish weather on Saturn has one more astounding surprise. And it's a true monster.
One of the freakiest storms on Saturn was this hurricane-like thing that they found down at the South Pole. Now, this storm is bigger than the United States.
The Great Red Spot on Jupiter is merely hurricane-like. That storm doesn't have an eye wall. However, the South Pole storm has the characteristics of a terrestrial hurricane, including an eye wall, making it the only such storm on another planet.
It's not clear that it is a hurricane in every sense, like we have here on Earth, but so far the morphology of it looks very much like a hurricane. That was very exciting. Everyone got very excited about that. It even surprised us.
And you can see right down into the eye, just as you can with a hurricane on Earth, and they can see farther into Saturn's atmosphere than they've ever been able to see before. So this thing is literally a window into Saturn. And it's amazing to see something so similar to Earth on Saturn, and then find out that we can actually do some science because of it.
The South Pole storm measures 5,000 miles across. That's 2/3 the diameter of the Earth. If a hurricane that huge were to form here, it would cover a distance from New York City to Baghdad, annihilating all in its path.
It's basically a swirling vortex of air that is centered around a hole right at the center with a walleye around it.
What powers this monster storm is still unknown.
And the winds are stronger on Saturn than they are on Earth, which is a puzzle in itself because Saturn gets so little energy from either the sun or from its own inside.
It's centered around the south pole of Saturn, rather than being, you know, in the equatorial region like a hurricane on Earth would be.
In early 2007, modern imaging technology revealed something else on Saturn that astounded scientists.
We see it very, very intensely now.
It's something big, something strange, and something never seen in the universe before. Saturn, the solar system's most bizarre yet beautiful planet, has just gotten even more mysterious. In 1979, the Voyager spacecraft showed a perfect geometric form over the North Pole. In October 2006, the Cassini craft found that it is still there.
It's just bizarre, and it sits there kind of still. It doesn't move with the planet. The pole, there's a hexagonal feature, a six-sided polygon that encircles the pole at about 78 degrees north latitude. And it's sitting there as a set feature.
The hexagon is similar to Earth's polar vortex, which has winds blowing in a circular fashion around the pole. Saturn's vortex can fit 4 Earths inside of it and extends 60 miles deep into Saturn's clouds.
And what's more bizarre, Voyager saw little tiny clouds going around at about 100 meters per second, which is about 200 miles an hour, going around this racetrack. People thought, well, maybe it's just a temporary thing. How could this stay there? It's been there now for at least 20 years, and we're going, what is this?
If you go there, you're going to enter these thick clouds. And the deeper you go, the more intense the pressure is going to get, to a point when you just implode. You and your spacecraft can't make it any farther.
For now, visits to Saturn's orbit are reserved for unmanned spacecraft. But surrounding the planet are at least 48 moons. Venturing to one of those is more feasible.
What's interesting now that we're going to the planets is that we're learning that, in some ways, the moons are where the action is.
We've already been to one of them. Titan is the only moon other than our own to have been explored. The event was beyond significant. On January 14th, 2005, science fiction became fact. As part of the ongoing Cassini mission to Saturn, the unmanned Huygens probe descended onto the surface of Saturn's biggest moon. Titan lives up to its name. It is the size of the planet Mercury. In fact, it is the second largest moon in the solar system, 50% bigger than our moon. It is seductive in many ways. For one, Titan looks much like Earth.
That was the thing that hit me over the head, just how remarkably similar in process the surface of Titan looked. We have river channels that feed into these lake beds. We have winds. And then in other areas, we have dunes. The equator region of Titan, at least on one side where we've gotten good radar imagery, has hundreds and hundreds of miles of these dunes that are 100 meters high, several miles apart, and they just go on, this vast sea of dunes.
There are possibly deposits of solid hydrocarbons.
And we didn't really know until that probe landed whether it was going to hit liquid or some solid surface. It seemed to kind of fall on what looks like kind of pudding. It doesn't seem to be liquid or solid. It seems that Titan has some goo on the surface. It's almost kind of neither land nor sea, but something in between. That's very amazing.
Amazingly, Titan, like Earth, has an extended atmosphere. No other moon does in our solar system.
The atmosphere of Titan is very, very thick, very, very massive. It has a mass that's 10 times the mass of the Earth's atmosphere. And so you have a very, very thick layer of gases. So it's thicker than the air as we know it. The particles in the air are also very small, and so I would characterize them more as a haze than as a fog or clouds.
The haze is 200 miles thick, resembling something else on Earth.
From the outside, it appears essentially opaque, like a big orange ball. But as the Huygens probe descended through the atmosphere, you know, it's transparent enough to be able to see the surface features as it fell through. But it's not unlike a hazy day here in Los Angeles.
It's not the color of the atmosphere that most intrigues scientists. It's the composition. Nitrogen and methane, the same gases they believe made up much of Earth's early atmosphere.
The idea that Titan's atmosphere mimics the atmosphere of early Earth 4 billion years ago is something we're very, very excited about and interested in, and it's one of the things we're studying very hard in our laboratory.
Let's see if we can get this aligned. What do we have?
At the University of Colorado, Dr. Margaret Tolbert is simulating Titan's atmosphere in her lab. Might it, too, have the necessary ingredients for life?
In this experiment, we're trying to simulate the chemistry that goes on high in Titan's atmosphere where the haze is forming. And so what we have is a reaction chamber here, and all that we have in there is nitrogen and methane. So the two most important components of Titan's atmosphere. And then we're just going to flick on a lamp, and that lamp is going to simulate the sunlight hitting Titan's atmosphere.
Incredibly, Tolbert's research has shown that Titan's atmosphere, when stimulated by sunlight, begins to produce organic compounds. To scientists looking for life beyond our planet, this could be big. As scientists scour the galaxy for signs of life, there are some exciting results from within our own solar system. Saturn's moon, Titan, seems to have the necessary ingredients. Testing at the University of Colorado has shown that when sunlight interacts with Titan's nitrogen and methane-rich atmosphere, organic compounds are created.
So these organics are floating down to the surface of Titan, and you can see them in the pictures, and who knows what they're doing once they're there. They could be providing energy to some new kind of life.
Further research is needed to determine if there really is life on Titan, or if it might someday develop. Although its atmosphere resembles early Earth, the environment is vastly different.
It's cold. It's 300 degrees below 0 Fahrenheit, and there's no liquid water. So that's a big difference between early Earth and Titan.
The lakes and riverbeds on Titan were carved out of the ground by something. There's no liquid water on the moon, so what flows on this terrain?
The hills on Earth are made of silicate rocks, whereas the hills on Titan are ice and methane ice. The river channels on Titan are formed by methane rain, as opposed to the Earth river valleys formed by water.
Liquid methane, it seems, rains down on Titan, or did at one time.
On Titan, it is so cold that gas has liquefied, and there are coastlines and rivers and all this terrain shaped by moving rivers of methane. It's just completely intriguing.
Methane is the principal component of natural gas, butane, and propane, all sources of fuel.
There's a lot of hydrocarbons. It might be very light hydrocarbons on Titan. And there's a lot of it, and it burns if you put it in contact with oxygen, so there's a lot of energy out there.
Enough on the surface of this huge moon to supply all of Earth's needs for a very long time.
Well, here's this tremendous supply of natural gas on Titan. Boy, wouldn't it be great to go out there and tap into it and bring it back? But I think that you would find that it would cost you so much to go out and get the methane and bring it back that you would never be able to effectively power anything on Earth with it.
While Titan is Saturn's largest moon, one of its smallest may be even more exciting. It's a brilliant ball of ice and rock called Enceladus.
It's a tiny object. It's only about 300 miles in size, so that's what, about the eighth the size of our own moon. And we've never seen a body that small that has activity on it.
This activity was discovered in 2005 by Dr. Carolyn Porco and her Cassini imaging team. One photo seemed to suggest that jets were coming out of Enceladus.
It seemed very likely to the members of my team that it's possible that these jets are actually geysers. They're erupting from pockets of liquid water not too far beneath the surface.
The closest thing we have on Earth to Enceladus is something like Old Faithful Geyser here at Yellowstone National Park, which is shooting water vapor and water about 150 feet into the air. The geysers on Enceladus are erupting water vapor hundreds of miles into the air because of the much lower gravity there and the fact there's no atmosphere holding them in.
Many geysers have since been discovered, all in a region of Enceladus's southern hemisphere.
They are coming out of these fissures, these big cracks that go on for about 135 kilometers, something like 80 miles of cracks.
We call them tiger stripes because when we first saw them, they really looked like the stripes on a tiger. There are 4 areas that seem to be ridges or kind of active geologic areas, and the plumes seem to be coming out of these areas. And we've counted about 20 or 21 plumes.
Southern Enceladus is covered in cosmic Old Faithfuls.
Who would thought that an ice ball about the size of Texas would be alive with plumes and geysers? I mean, it's astounding.
Enceladus is heated in its interior by the tides of Saturn. The Earth's moon is pulling on the Earth's oceans and distorting their shape and producing the tides that we're familiar with here on Earth. But on Enceladus, the planet Saturn is pulling on that moon, and as Enceladus goes around in its orbit, that pull is changing and the ice inside Enceladus is creaking and groaning and rubbing against itself and creating a lot of heat through friction. We think it's that frictional heat that is producing the evaporation of the water ice that is then escaping through these cracks and making the geysers that we see there.
And there's more. Enceladus's eruptions have clarified a theory of what powers one of Saturn's rings.
We knew there might be jets, something coming from the surface that was injecting material into orbit around Saturn to form the E-ring.
The E-ring is furthest from the planet, about 74,000 miles away.
It happens to be just at the same orbit, the same distance from Saturn as Enceladus. And so it really suggests that it owes its origin to Enceladus. And thickness of the E-ring sort of matches the thickness of particles that were ejected from the south pole of Enceladus.
If these geysers disappear, so might the ring. Ultimately, the liquid jets suggest that there is water on Enceladus. And perhaps something else.
So the search for water is not that, oh, one day we'll be thirsty, so we'll have something to drink. The search for water is guided by our interest in the search for life. It's that simple. Follow the water.
Saturn's moon Enceladus is one of the most exciting and least understood places in our solar system.
Enceladus is a really strange place. The strangest thing that got people's attention first is it's very, very bright. It's the whitest object in the solar system. And we now realize that it is covered in freshly fallen snow, which is the ice that's fallen back from these geysers onto the surface.
And it's that ice that has scientists excited.
Possibilities there are amazing. The search for water in our solar system is ultimately a search for life. You look for water in the hopes that maybe there will be life.
Because of the presence of ice, some experts believe the search for alien life should begin on Enceladus.
It has a lot of other molecules in it, a lot of other exotic things, which show us that there's probably aqueous chemistry going on underground. So there's a lot of little percolating kind of chemistry going on, and maybe you could get biology, maybe, and so maybe we should go look.
This is kind of the holy grail of modern-day planetary exploration, to go and seek out those environments in the solar system where life might possibly have gotten started, and we just stumbled upon it. Is that exciting? You know, I mean, of course it's exciting. It's the kind of thing scientists live for.
We know the composition of the gases that are coming out because we've flown through them with the spacecraft, and we've got the composition including carbon and nitrogen and all those goodies that you need to make life. And then we know there's a source of energy from the frictional heat or the tidal heat in the interior, and we can see the heat on the surface. So all these elements are there that might be sufficient to sustain life if life could have got started there. So that makes Enceladus a very exciting place.
But what kind of life?
We're not talking sushi, you know? We're not talking lobsters and fish, we're talking microbes. I think that's about the best that we can hope for on a moon like Enceladus. If we ever discover such life in our solar system, it's going to be the simplest possible. It's going to be bacterial, or something like it.
Even the discovery of something small would be a huge event.
It would change everything that we think and know about our solar system, the universe, and ourselves.
Much of what is known about Saturn and its moons has come from the Cassini satellite that was inserted into the planet's orbit in 2004. It is currently touring its rings, moons, and the planet itself. By 2008, Cassini will have made 70 trips around the gas giant.
Putting an orbiter around a planet and being able to hang out there and monitor the system and all the different elements of the system for a long period of time, I mean, that's the best way to study these bodies.
Scientists on a daily basis process the information sent back from these close encounters.
In addition to the camera, there's a radar that can send its radio waves through the clouds, get an echo off the surface, and make an image of the surface. And then there's spectrometers to measure the composition and other infrared devices to measure temperature. So it's a very comprehensive spacecraft.
As you see better, you learn more. I think it may have been Yogi Berra who said you can see a lot just by looking.
Relating this information to processes on Earth could help explain mysteries of our own planet.
Saturn is really very different from the Earth. Its diameter is 8 or 9 times greater than that of the Earth. Its atmosphere is made of hydrogen, completely different from our own atmosphere. But the same physics is going on. The same forces are controlling the weather on Saturn as are controlling the weather on Earth.
It is part of our history. It's the solar system. So understanding how our solar system formed is really understanding how I got here. And understanding the nature of the other planets that are in the solar system. I mean, they're like my neighbors.
Cassini's new imaging technologies are giving us never-before-seen views and information by the day. Cassini's close encounters with Saturn will bring us nearer to unlocking its secrets.
It's quite complex, and it'll take us a long time to figure it all out. I don't think we ever will figure all of it out. But it's just the beauty of being able to be in orbit and monitor a rich planetary system like Saturn's.
The Earth has a context in the rest of the universe. And you want to know where we fit in the universe? You don't get the answer to that just studying the Earth itself.
For as much as we discover about the Lord of the Rings, it will always inspire us. In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe. It is the showstopper of our solar system. Basking in its own glow, it seduces all admirers. However, it is a beauty with a mean streak. It's a massive, frigid ball of gas, surrounded by icy rings, hurtling at 40,000 miles an hour. It is a planet of violent weather, with a polar storm bigger than the United States of America.
Saturn has some of the most powerful weather in the solar system. The lightning can be 1,000,000 times more powerful than lightning here on Earth.
But its moons are even more exciting.
The geysers on Enceladus are erupting water vapor hundreds of miles into the air because of the much lower gravity there and the fact there's no atmosphere holding them in.
Another has an atmosphere with oceans and mountains. Could life exist on one of these moons? Saturn, Lord of the Rings. If there is one planet that represents the majesty, mystery, and awe of the universe, it is Saturn. It stirs emotion, even from scientists who are stunned by its cosmic perfection.
You gotta hand it to Saturn for being the most beautiful thing out there. It's been my favorite planet since I first saw it through a telescope.
While it looks sleepy and serene, the sixth planet from the Sun is anything but. Saturn is a dynamo whose beauty is skin deep.
Saturn is an absolutely frigid place. You wouldn't want to step out on the surface. For one reason, you'd fall because there is no surface, but secondly, you'd freeze to death instantly.
Saturn is a hunk of hydrogen and helium that races around its axis, distorting its shape.
When you watch a professional toss a pizza, as it spins around, it flattens out. So it's the same kind of idea. Because it's spinning so rapidly, it's actually sort of squashed, sort of bulges in the middle. It's called an oblate spheroid.
Even though it's much more massive than our own planet, you'd actually weigh slightly less on Saturn than you do on Earth. A 150-pound human would weigh only 137 pounds on Saturn. That's because Saturn has such a low density, the only planet in the solar system less dense than water.
Saturn is so bloated, the gases take up so much space compared to the total amount of mass in Saturn that its density is less than 1. So if we could get somehow some really big ocean and put Saturn in it, it would float.
Saturn is the second largest planet in our solar system. It is a gas giant, a mass of hydrogen and helium 750 times the size of Earth. A day on the planet is 10.6 hours long, and it takes 29.5 Earth years to orbit the Sun. It has 48 named moons. Saturn has been around for 4.5 billion years, It formed by accreting carbon dust particle by particle into a rocky core several times the size of Earth. Then it was able to attract gases like hydrogen and helium, which collapsed under gravity.
As things started collapsing, this cloud began to compress. It began rotating more rapidly, but along its axis from, let's say, top to bottom, it wasn't rotating, so it was free to collapse under the force of gravity.
It's called the conservation of angular momentum, a principle on display at your local ice rink.
If you push your arms out, if you're an ice skater, you'll go more slowly. If you pull your arms in, then you'll be more concentrated towards the axis of rotation and you'll have to spin faster. And that's just what happens for a planet as it condenses.
A spinning Saturn came out of this collapsed disk. The feature that has made Saturn the most iconic planet in our solar system is her majestic, shimmering rings. They are incredibly big, 173,000 miles in diameter, wider than 21 Earths side by side.
So it would take you 2 days in a really fast rocket ship to get from one side of the rings to the other. They're huge.
However, these huge rings also are unbelievably thin, measuring about 65 feet. When viewed from the side, they virtually disappear.
They are no thicker than about 1, maybe 2 stories in a modern-day building. They're paper thin in comparison.
The rings may look like perfect solid disks. However, they are actually made up of billions of pieces of space debris. But what exactly are they?
They are countless icy bodies that range in size from objects as big as houses all the way down to the finest powdery snow you might ski on in Utah. And they're made of water ice.
They're particles that have been pulverized, so they've smashed into each other. They've broken up into many, many little particles.